All right, so today we're going to talk about solving systems of linear equations, and we're going to cover three sections. Section 7.1 is on solving a system of equations by graphing. So a system of equations will be more than one linear equation that would be plotted again on the Cartesian plane, and of course when we're solving a system, our solution is going to be an ordered pair that satisfies both equations. In other words, that ordered pair will make both equations true. That means that point is going to be on both lines at the same time. The intersection of those lines is the solution. Remember that we're always going to make sure that we are going to check our solution algebraically after we've solved it graphically to make sure that we're right. So here's our first system. And 3x plus y equals 11 and x minus 2y equals 6. Now these equations are in standard form. Standard form having the x and the y on one side and a number on the other. I'm going to graph these using slope-intercept form. So I've turned the top equation into the red equation, and so my slope is negative 3. I'm going to go up to the y-intercept at 11, and I'm going to plot the y-intercept at 11, and the slope is negative 3, and there's the equation of the red line. Graphing using slope-intercept form. The green line I also put in function form, and got the y by itself on one side, and my intercept is negative 3, my slope is 1/2, so this is the graph of the green line. So our solution is going to be the point where both of them are, it's going to be the point where both of them intersect, which is going to be, of course, right here. Okay? Right there. And it looks to me like that's about 4, negative 1. Now at this point, we need to check it algebraically to see if it actually is at 4, negative 1. And to do that, we're going to plug 4 in for x and negative 1 in for y in both equations. When we do this, the top equation has 11 equals 11, and the bottom equation has 6 equals 6. So 4, negative 1 is the solution. That is one example problem on how to solve a system using graphing method. So 7.2 is going to be on solving systems by substitution. And the very first thing that we're going to do when we solve a system by substitution is to get one of the variables by itself on one side in one equation. And then we're going to substitute that equation, the other part of that equation, into the second equation. When we're done, of course, we'll check our work algebraically just the same. So here we go again, two equations. And in this problem, I would choose to solve for y in the top equation because the y is a positive value. So I'm going to subtract 3x from both sides, and I'm going to get y equals negative 3x plus 5. At this point, it's time to go ahead and make the substitution. So I'm going to substitute negative 3x plus 5 into the negative y in the upper equation. Alright, so the negative 3x plus 5 goes up in for the negative y in the upper equation. The negative out in front of the parentheses is the number one missed part of this kind of a problem. So now when we solve 2x minus, in parentheses, negative 3x plus 5, that negative sign gets distributed through the parentheses. And so that's going to be a negative 3x turns into a plus 3x, and 2x plus 3x is 5x. You'll notice that the positive 5 that was inside the parentheses becomes a negative 5. And now we just solve the linear. And we have x equals 3. Now, of course, this is only half of the problem. Because we're looking for an ordered pair answer, we now have to use backward substitution and put that 3 back into one of the other equations. So I'm going to plug that 3 into the top equation and multiply it out. And so I'm going to solve for y. Y is negative 4. And if you left your answer like this, I would mark it wrong because we're looking for an ordered pair solution. So I want to see an ordered pair. Guys, we would now plug that number back into both equations to see if it's true. I'm not going to show that right now. We're going to go on and get into solving a system by the addition method. So 7.3 is called solving linear systems by linear combinations, elimination. I call it the addition method. So it's a third method to do the same thing. Our first step is to get the equations lined up so the x's are over the x's and the y's are over the y's. Next, we have to get one of the variables to be equal in magnitude and opposite in sign, and then we're just going to add the equations. So those are the steps. You can come back to this if you need to see it. Here's our two equations we're going to solve for. Now, right off the bat, we can see that the second equation isn't in the same order as the first equation. So we're going to have to add y to both sides to get there. That's our first step. Our second step is to pick a variable to solve for. Our choice is now, which variable do we want to eliminate? Do we want to eliminate an x or do we want to eliminate a y? In this case, I would choose to eliminate the y variables because there's a negative y and a positive y. The only thing is, the top equation coefficient is negative 2. The bottom equation coefficient is positive 1. And so I'm going to have to multiply one of the equations or both of the equations to make them equal in magnitude and opposite in sign. So I'm going to multiply the second equation by 2. When I multiply the second equation by 2, now the variables line up, and now it's just time to put a line underneath them and add them. So 3x plus 4x is 7x, negative 2y plus 2y is 0y, and 4 plus 10 is 14. Solve for x. And when we solve for x, we have half our answer, half of our ordered pair. So x is 2. We're going to use substitution in, the x in, and we get y is 1. So our ordered pair solution is 2, 1. And again, we're going to check it algebraically. And that's solving systems of equations by graphing and substitution and elimination. Here's one more. Again, the first step is to get the variables on one side. And in this problem, I would choose to get rid of the x values because one is a positive x and one is a negative x. So I'm going to multiply the top equation by 4 and the bottom equation by 3 to make the x values the same at 12 and negative 12. And then now when I add those, I just have y values and I'm going to get a fraction. This is going to happen. When you get a fraction, you are going to have to plug it back in and you're going to have some good fraction abilities. So our solution is an ordered pair with fractions. We're going to check it and we're going to be done.